Okay, hello everyone. So this is a lecture, well, leftover of the monetary policy lecture that I haven't finished in class. I'll post this on YouTube somewhere, and then you can listen to it, and you'll be able to follow the slides a little better. So we finished with Taylor rule, and there was a question about whether we are going to be testing anything or anything after the Taylor rule is going to be examinable or not, and the answer to that question is it is examinable. The new Keynesian model, the complicated one that we overviewed, that's not going to be examinable, as I said in class, but everything after that model in the lecture notes that you are looking at the moment, that's all examinable. So the Taylor rule is after John Taylor of Stanford, and it's basically an idea that the monetary policy should be responding to inflation differences from target and output differences from GDP differences from target. The coefficients alpha, or what is it, a.p.a. and a.y, are something that the policymaker chooses. And the one that you're looking at is the standard Taylor rule. Right, it basically recommends a relatively high interest rate when inflation is above target. That's because a.p.a. is just like a.y. Those two coefficients are both greater than 0. So if inflation is above target, nominal interest rate needs to rise. Furthermore, it needs to rise more than proportionately. You can see that from the fact that inflation is both, you can see my cursor, so mouse cursor. So inflation is both immediately on the right of the equation, of the equation sign, and it's 1 for 1. So if pi goes up, if inflation goes up, the left-hand side goes up by the same amount. But then inflation is also present in this Taylor term, and it has some positive coefficient. So nominal interest rate needs to go up by more than 1 for 1 with inflation. Why? Because the whole point is that the nominal interest rate should rise. The whole point is that the real interest rate should rise. So if inflation goes up by 1%, nominal interest rates rise by the same amount, 1%. Then a real interest rate, which is of course just the difference between the two, is not going to change. And if real interest rate doesn't change, then we would expect that the firms are not going to respond in any way, because in real terms, in real terms of real output, it doesn't cost them any more to borrow, to invest stuff, so they're not going to change any behavior, and then it has no real effect. So Taylor rule proposes or suggests that you should respond more than proportionately to this in order to move, the policymaker should respond in order to move the real interest rate in the desirable direction. So that's that part. It also should respond to output gaps. So if you have a recession, then you should lower interest rates. What are the problems with it? Yeah, well, it's difficult because you don't really know what the GDP is at any point of time. So you may be guessing you're in a recession, but you don't really know. So often the policymaker, the central bank, would be trying to forecast what exactly is the GDP going to be in the next couple of months or year or quarters, and then based on that they try to figure out what's the right interest rate they should set. And obviously these coefficient sizes, a.p.a. and a.y, those are things that you can pick as a policymaker. So how do you select them? That's unclear also. In fact, it could be that you select, some policymaker chooses these coefficients to be so large that instead of helping the business cycle, helping to smooth the business cycle, so get out of a recession, it could go as far as create an expansion. And this is actually something that has been argued that, so there's discussion about whether Alan Greenspan in the Fed has artificially caused a very protracted expansion in the United States back in the 90s. But that's for another time. All right, so inflation targeting is another policy that the central banks use as opposed to the Taylor rule, and it's been invented in New Zealand, but it's being used around the world explicitly or implicitly by very many central banks. So explicitly, the main ones are Bank of Canada, Bank of England, Bank of Finland, I think that's a mistake, never mind. Bank of Finland obviously doesn't exist, doesn't set monetary policy anymore because it's part of the Eurozone, so that's a typo. Swedish Riksbank, Central Bank, and RBA, Reserve Bank of Australia, as well as other places. So ECB does not explicitly, European Central Bank does not explicitly follow inflation targeting, but they do have a policy which says prices should be stable, so it's as if they were following one. It's kind of similar. All right. So according to this rule, the central bank does, what it does is then it announces that it wants inflation to be X%, and then it does anything nitty-gritty in the background that it can and that it needs to do to make sure that that actually happens, right? So it'll be adjusting the interest rates accordingly until inflation is at that level. So it doesn't really say follow a particular rule for interest rates, any kind of a formula. It just tries, well, carefully tries, I guess, to adjust interest rates up until the point when they find inflation to be near the target. As we have discussed, this is a problematic in part because you can't control inflation directly, and inflation takes a long time to change, so prices are rigid. So, you know, you might have inflation in New Zealand right now is 0.6% or 0.1%. It should be at 2. Well, it may take a long time to get there, and you don't really know how strongly you should be responding with monetary easing in New Zealand. Right, so it has to be manipulating things, but it's nice in a sense that it's, well, if it is a credible target, it is a very good system because people don't really care about what the interest rates are. They just when firms make long-term projections, they want to know, they want to be able to take expectations of inflation into account. And if they can rely on central bank to provide these expectations by the target, by the central bank announcing an inflation target, and if the target is credible, then it creates certainty for the firms to make decisions. So, but the problems are that you can't control inflation level, price level and inflation rate directly, so it requires a lot of tinkering, and not all of it is understood very well. Right, I think that's pretty much it on this slide. That brings us to the problem of monetary policy credibility. So this is something that's been a big hot issue in the 80s and 90s, but as you recall, inflation is sticky or rigid, so prices don't change very quickly. So inflation goes up and down, but it takes time. Now, and we also remember from from previous lectures that, or from Econ 200, from Macro 200, that if monetary policy stimulates the economy, it will create an expansion, so GDP goes up. So let's say I'm a central bank and I am inflation expectations have been managed already. So inflation is, let's say, at 2% on the target. Everybody expects it to stay the same. But my friend, the Prime Minister, says the election is coming, and we have a little drink in a bar the other day, and he says, "Man, I'm really worried that I'm not going to get elected." Right? So, and he's your good pal, and well, this is not New Zealand, let's say. So you want to help out. What can the central bank do? Well, it can suddenly and surprisingly create inflation by lowering interest rates or increasing money supply, whatever it does. And that will eventually create inflation. So if it's a surprise, because inflation takes a long time, it will eventually create, this sudden monetary policy easing will eventually create inflation. Initially, it doesn't. So initially, this stimulus only creates more GDP. Well, interest rates go down, everybody borrows to buy stuff and invest in things. That creates more GDP, more investment, more consumption. So you can stimulate the economy temporarily by surprise monetary stimulus. So, of course, eventually that will lead to inflation, higher inflation. So this is something that is called the inflationary bias of monetary policy if the monetary policy is discretionary. In other words, if it's completely up to the discretion of the central bank what it does, if it does not have to follow any rules or abide by any rules. And it's you can think about it as the loss function at the bottom of the slide, which is what the central bank is trying to minimize. It cares about two things. The central bank cares about both inflation and output. So we don't want to be in a recession, but we don't want to have a high inflation. Unfortunately, the two of those things are negatively related. So having more inflation will also create more GDP. Having less inflation will also create less GDP because the central bank is moving the demand curve, not the supply curve. So you don't like both of these things, but they are inversely related, so you have to kind of choose. But because inflation is sticky and the price expectations or contracts by firms are set up long time in advance, they will not immediately change. Maybe for half a year or a year they won't change if you surprisingly stimulate the economy. So you can do a better outcome for a short period of time by simply doing a surprise monetary stimulus. You create more GDP, inflation doesn't change until later, right? So it's a bit of a problem in that sense, but of course that's, as I said, was a problem in the 80s, so people have figured it out. That's the next slide. So the way that you can solve this inflationary bias of monetary policy is by, first of all, the most basic one is sort of self-managing solution is a reputation. So if the central bank wants to be reputable, it can't just say that it wants inflation at 2% and then do surprise stimulus. That would just mean nobody believes anything that the central bank says. And there are some nice cartoons from 1980s when the Reserve Bank of New Zealand was talking about 2% inflation target, and the cartoonist wrote or draw a flying pig above the newscaster, saying another RBNZ prediction inflation will be 2%. Right. So, reputation is kind of hard earned, and when it's earned, the bank would not want to lose it, and therefore that should sort of self-police the bank to avoid doing these surprise inflationary measures, which would create more GDP. So it's kind of a nice thing temporarily, but it loses credibility and reputation. The second solution is something that was suggested by Gordon and Rogoff in their paper. It's delegation to a conservative central banker. So rather than having an everyday Joe in the central bank, you will have a conservative person who really dislikes inflation around the central bank. He or she will then be will not have a tendency to create more GDP because they will not care about the GDP as much as they care about inflation. So conservative meaning somebody who's hawkish as opposed to dovish. Finally, central banker contract, which is what the RBNZ New Zealand Central Bank does. So you literally write a contract with the governor, not you, the government writes a contract with the governor which says this is what you have to do in the medium run to keep inflation in this range. And when your job comes for a review, that's what it will use to judge. So delegation and simple contract. Institutional structure of the central bank, so you can have other incentives to avoid central bank overstimulating or creating surprise inflations. Yeah. Okay, that's basically it. All right, so that's about it for now. Just some empirical stuff about monetary policy. So, is monetary policy working? So, as we said earlier, if prices were immediately adjusting, central bank would have no job; they would be out of work. But prices don't immediately adjust, and therefore central bank should be temporarily able to help or worsen, depending on what it does, the economic situation. But in the long run, it should be all neutral. So the way that people measure this in real world is something called, they look at variables and how they move. So they look at inflation, they look at money supply, and they look at GDP, unemployment. And literally the way they measure it is something called the Granger causality. So we'll use that term a little bit, but basically it means if variable X changes first and variable Y changes right after, then X Granger causes Y. Of course, that does not mean that X actually causes Y. For example, Christmas cards come before Christmas, but it doesn't mean that Christmas cards are causing Christmas, obviously, at least last time I checked. All right, so in the long run, as you would expect, what we've been trying to bang on for months now is that in the long run, money is neutral. So inflation and the money growth are very highly correlated in the long run. So all that more money does is create, in the long run, is create higher price levels. So, and that is true. So correlation 0.96 to 0.92. Of course, there's no causality there again, but there are Okay, if you just look at a correlation, it means it doesn't tell you anything necessarily about causality, but people have found out that this is causal. So inflation is a result of growth of money, most and foremost, but this is only in the long run, so we look at 5-10 year horizons. If you look at nominal variables and the rate of growth of money, they're also very highly correlated. And real output growth, GDP growth, and real money growth real GDP growth and money growth are uncorrelated, or inflation are uncorrelated. But for very high inflation countries like Zimbabwe back a few years ago, and other countries, so if you have hyperinflation, then it's really bad. So then you have typically, if you have very high inflation, then you have actually negative correlation with GDP growth. And unemployment and inflation, so the whole thing of Phillips curve, unemployment and inflation, is only a short-run relationship. So in the long run, there is no correlation. And so the long run, short run is, of course, the way you would also expect. So short run, money leads output. What that means is money changes happen first, or happen before output changes. That's called leading or lagging a variable. So money leads output. Positive correlation between GDP in period T and money, money supply period T minus S, so a couple of months back, for some positive S. And it's been known for a while, since 1970s. Also, it helps, so you can use money, if you want to make a buck forecasting output, you can actually, in the short run, you can use money supply. So money supply is a pretty useful in the short run forecasting output. Hump shape. So I'll show you a few figures in the next slides where you'll be able to see what it looks like. Contractionary, of course, does the opposite. So contractionary monetary policy, so increase interest rates or lower money supply, causes higher interest rates, lower output, higher unemployment or lower employment. Wages, profits also go down, right? And it takes about 1 year for this effect of monetary policy to wear out. So that kind of gives you the lifespan of monetary policy. So monetary policy works for up to a year. But then it kind of, once prices change, not much is going on. So it's just, well, it would be neutral. It just goes higher prices, but nothing else. All right, so there'll be a few figures coming up. Non-trivial effect. Yeah, there, you can read that. Okay, there's a figure. So an increase in output during, so there's a matrix of figures. There's 4 by 4, so 16 pictures. In the row, so each row is a response of a particular variable. And each column is the shock. So what are we responding to? All you need to kind of look at here, the most important one is the first column. The first column tells you what's happening when interest rate R, which is set by the Fed, in this case is the US, changes. And the way you read it is you go down that figure and you look at the first picture, and the first one is just a response of interest rate to interest rate change. So it just shows you the path of interest rate. It doesn't really tell you much. The second row is M. So how does money respond to increase in interest rates? So it's a monetary policy tightening, of course. Interest rates going up is a tightening, so you would expect money supply to go down, and it does, and it stays down. It eventually comes back up. Okay, and then we have prices. So that's a bit peculiar. Why do prices go up? So prices respond with a delay. Okay, so typically when you would, so the key picture anyway is going to be the last in the first column, so the fourth row in the first column. But let me just talk briefly about the third row in the first column. So that's what happens to prices when interest rates are increased. And this is just an estimation from a VAR, which you don't really know what it is, vector autoregressive regression. But what this does is estimates what happens to these variables statistically when interest rates are suddenly increased. Right? But typically interest rates are increased for a reason. So interest rates would be increased because inflation is too high. And because prices take a long time to change, it will take a bit of time for this price growth to slow down. So, you increase interest rates today because inflation is running at 5%, let's say. Inflation is not going to drop to 0% tomorrow. It'll take, possibly a year or two for inflation to go back down. And that's why the price row there, so the response to prices, at first is they still keep on going up, but then they start going down. And if you look at the 6-variable model, They just continue to go down. So that the general longer run, medium run response of prices is a decrease to an increase in interest rates, but it's hump-shaped. And finally, the bottom one is the key one. So that's GDP. So what happens to GDP when we increase interest rates? Initially, there's a little blip upwards. What you don't see here is the confidence interval, so that would be insignificant. But then it goes down, right? So the decrease is by almost 1%. So the increase in the shock was increase in interest rates by, I think it's 67 basis points, so 0.67 of percentage point. That's my interpretation. I'm not really sure. So it's a very large interest rate increase, and it causes a decrease in output growth by about 1%. 0.79, I think, is the bottom there. In any case, so these are just some numbers, but the bottom line is this is the view of the data. This is not from a model. This is actually what the world tells us, and the world tells us, yeah, the monetary policy in the short run works. It influences real GDP and unemployment in the expected direction. So that's basically what it is. Conclusion, money is not neutral in the short run, as we have said, and it's neutral in the long run. So we would hope to have the right institutional setting for a central bank so that it can help economy ride these waves up and down, just kind of smooth them over time. All right, next I'll record some other stuff, but it won't be today, about financial markets. Okay, have fun. Bye.